Welcome back to Hogtech University. I'm Andrew Behrens, welding engineer and certified welding inspector. This is Welder Training Unit 6, Gas Tungsten Arc Welding, also known as TIG welding. The objectives for this course are to cover the process basics, equipment setup, tungsten selection and grinding, weld angles, and techniques. So, starting off with the basics. Gas tungsten arc welding uses a non-consuming tungsten electrode and shielding gas, typically argon, to establish a stable arc. The filler metal is added manually into the weld pool. Voltage and amperage are varied in this process. The voltage is varied automatically to maintain a stable arc, while the amperage is controlled by the welder manually, typically with a foot pedal or with a button or dial. Equipment setup. First, always check that you're plugged in. Next, the power switch is on the back of the equipment. Check your argon gas, make sure you have enough gas and that is turned on and flowing. Place your ground properly. And get comfortable with your pedal or switch in whatever position you're going to be working in. Lastly, grab your filler rods and you should be ready to go. Equipment settings. There is one main setting on the gas tungsten arc welding machine, amperage. This is max amperage, since your amperage will be varied with your foot pedal or the dial that you're using. All the other buttons you're seeing on the front of this machine are for other types of settings. So additional settings is going to be AC current, where you can have a sine wave or a square wave. Frequency, which is the rate at which it will change from positive to negative. A lower frequency will give you a wider cone with less penetration, typically more around 60 Hertz. A higher frequency will be a narrower cone with more penetration, more commonly used, which is around 200 Hertz. This is typically used for aluminum, AC welding. Pulse arc is similar to AC in that it uses a frequency to increase and decrease the power. However, it does not change the polarity of which you're working. So when you're setting this, you're going to see amp, which is your peak amperage, so that's your max amperage. Your pulses per second, so how many times it changes between low and high within 1 second. Your peak time percentage, which is how long the high and how much is low. And then the background amperage, which is when it drops back down to the low, what is it going to drop back down to? So when you're setting this and you're looking at it, if you're looking at one pulse, so if you have 1 pulse per minute and you've got a 50% peak time, then you're going to be half a second high, half a second low, half a second high, half a second low. That can be elongated or shortened as needed. Tungsten selection. We have 3 types of tungsten on hand. Red, which is 2% thoriated. This is used on steel, stainless steel, and it handles high amperages better than others. Green tungsten, which is pure tungsten, which is good for AC welding, which is almost exclusively used with aluminum. And gray, which is serenium, which is serrated, is a multi-purpose. You can use it AC, DC, you can use it on steel, you can use it on aluminum. Again, if you're using it on aluminum, segregate for aluminum. If you're using it on steel, segregate for steel. But it can be used it's an all-around, all-purpose one. It does not handle the high amperages as well as the red, and some people like it better than the green when welding aluminum. However, the green seems to carry the arc a little bit better for some people. Just depends on your individual preferences there. To note on the red tungsten, the red tungsten is thoriated, which means it is slightly radioactive. No, it's not going to hurt you. The only real danger that comes from it being radioactive is the radioactive dust created when grinding it. So use the vacuum system in the Piranha 3 when grinding the red tungsten. That will collect the tungsten dust and it will not be a hazard. Tungsten grinding. The rule of thumb is that the length of the grind should be 2 times the diameter. There's a grind angle chart on the tungsten grinder to help you with this. The grind should be in the direction of the point And again, this will be automatically taken care of when using the tungsten grinder. So, setting up the tungsten grinder. First, you set the grind angle for the diameter tungsten using the chart provided. You check to see if there's a groove on the wheel, and you're going to move it up and down as necessary to avoid putting a groove or a weak point in the grindstone. Use the tungsten holder as necessary so you have a good firm grip on the tungsten. You put it into the correlating hole and roll it against the wheel, and that will sharpen your tungsten. There is also an area to blunt the tip as desired, and if you have a lot of crud on your tungsten and you can't fit it into the appropriate hole, there's a cutoff wheel which can be used to clean the tungsten or make a whole new tip if necessary. Tungsten setup for aluminum can be slightly different. Additional steps, they're recommended but not always required. You can grind the tungsten normally for the diameter. Then on the very end, you reset the angle for about 60 degrees and grind just the tip of the cone down to a 60 degrees. This will allow the tungsten to ball up more uniformly when using AC current. Welding angles. Just like all the other processes, the travel angle is a linear angle to the weld, and your work angle is perpendicular to the weld. So if you're looking at a T-joint, you're going to be talking about 5 to 15 degree travel angle with 45 degree work angle from each surface. The weld angles are very similar to all the other processes. However, since this is only a heat source and does not use a consumable, the heat source can be focused and moved around to where the heat is needed the most without interfering with the quality of the weld. When welding to similar thicknesses, you can focus that heat on the thicker material and then lap up and just touch the thinner material. Or again, you can add in molten material, and molten material will follow wherever it's hottest. So you can actually add in material and then move it to where you need it in the molten pool and in the weld puddle. So you can move the material around just using the heat source. For gas tungsten arc welding, you can weld forehanded or backhanded. Forehanded welding is considered the normal because you're displacing the gas ahead of the weld while protecting the weld pool. Backhanded welding is also used, and that's used primarily to protect the weld behind you as it cools and to add a cooling effect to the previously welded joint. So welding forehanded or backhanded is acceptable just depending on whatever circumstance you're looking for and whatever you need. The techniques are again very similar to all the other welding processes we have covered so far. However, again, because it's only a point heat source and not a consumable, you're going to move the heat source around and add in your filler manually. So when you're moving in a straight line, you can just hold the heat source on there, give it a little bit more amperage, get it to fully give you that nice round puddle in your joint, and just keep dabbing in your filler. For zigzag, you can move your heat source between the two, actually flowing the material around the part between the two plates as needed. And you can also do the circular motion, works very well with this, especially with adding lots of filler material, because of the motion of when you pull back your torch on the circle, you can add your filler, circle, add your filler, circle, add your filler. So that's a very commonly used technique as well. Weaving in gas tungsten arc welding is also commonly known as walking the cup. This is because when weaving, you can commonly put the cup onto the plate and rock it back and forth between the two joints to weave the material together. It comes out with a very nice looking weld in the end. When adding the filler metal into it, the filler wire should be added into the molten pool and allow the heat from the molten pool to melt the filler metal, not the arc. If you're melting the filler material with the arc, it adds droplets on top of the metal that are not fused in, and you're literally just dripping metal on top of each other. You're not fusing it in. Always add the filler to the molten weld pool. It's typical to move the arc out of the way while you add the filler material in without impacting the weld pool. So you don't want to stick your tungsten into the weld pool. You don't want to stick your rod to your tungsten and short out. You want to pull that tungsten back a little bit, add the filler, and just keep moving along. That's why the circle technique is very, very common, because you're constantly swishing that material around And you can just add as you move the torch in a circular motion. Again, depending on the weld joint, sometimes the arc can remain constant and just allow the filler to be added continuously when you're doing like a straight line draw. So if you got your arc high up off of the material, you're giving it lots of amperage, you got a nice weld pool formed, you can just sit there and hold the torch constant and just keep adding in the filler material as you go along. So there's lots of different techniques to use with gas tungsten arc welding. Find what works best for you. There's no correct answer on this. The correct answer is the one that gets you the highest quality weld for you. So in recap, you were talking about your equipment settings, setting it up direct current, pulse arc, AC, whatever you need for whatever you're using. Tungsten prep is very important. Clean your tungsten, make sure it's good. You don't want any contamination coming off your tungsten. And then just practice with different welding techniques. Find what works best for you and what works best for the joints that you're working on. Again, thank you for watching HogTech University Welder Training Unit 6. I'm Andrew Behrens, and we'll see you in the next video.